Good morning. In today's session, we are supposed to start our third unit, that is the random process. So, the random signals which will occur in a communication system, if these functions are of a time, at that time, we can call these as a random process. It means what? We can say about the random process like it is a time varying functions that assigns the outcome of a random experiment to each time instant x of t. It means what? If we are saying there are the random signals which are having the function that of time. At that time, these signals we can call as a random process. So we can say random process is nothing but it is a random variable, but we are giving them a time. So we can say random process is the extension of the concept of the random variable. But in case of random variable, we map the outcome of the random experiment into a number. If we are taking any random signals like noise at that time, we can describe that random signal as a function of time. And as we are describing the random variable as a function of time, we can say that as a random process, or the other alternate name for the random process is the stochastic process. इट मीन्स व्हाट? रैंडम प्रोसेस बोल सकते हैं या फिर हम बोल सकते हैं उसको स्टोकैस्टिक प्रोसेस. सो इफ वी आर सेइंग एनी रैंडम सिग्नल विच इज taking a concept of time function. So here if we are giving that random variable, random signal as a function of time, we can say that as a stochastic process. It means what? For fixed sample path, random process is nothing but it is a time of varying function. We can say like a signal. So if one scans all possible outcomes of underlying the random experiment, we shall get the ensemble of that signal. So here we are supposed to study about the random process, its basic concepts. So here we are saying random process can be continuous or a discrete. So if we are saying random process, we can say real random process can be called as a stochastic process. We can take example like noise source. So here we are supposed to study about the concept of deterministic and the random process. So there are some subtopics like we are supposed to study about the random process like its stationarity, ergodicity, its basic properties of a single random process. Then we are supposed to see about the basic properties like its mean, standard deviation, autocorrelations, convolutions, spectral density of a random process. Then we will see the joint properties like a covariance, correlations of two or more random process. We can see there about the cross spectral density, correlation, covariance and a simple input-output relations. So firstly we will see our first topic, that is the deterministic and a random process. So here we are saying if we are taking the random signals that are having the function of time at that time, we are saying these as a random process. So we can say random process can have discrete as well as a continuous value. So if we are talking about the deterministic and the random process, both continuous functions of time, and we are supposed to see here its mathematical concept. So here, if we are saying the process, random process, as a deterministic process, we can say deterministic process has only one possible reality of how the process evolves under time. It means what? It is the physical process which will be represented by explicit mathematical relation. And we are saying deterministic random process will have only one possible reality of how the process evolves under time. And in the random process, there are some uncertainties in its future evaluations which we can describe by its probability distributions. So even if initial conditions is known, there are many possibilities for the random process that it might go to. But some paths are more probable and others are some less probable. So here, if we are saying the process, random process as a deterministic, it means a physical process is represented by the mathematical relation. And here we are saying process as a deterministic if it has only one possible reality of process evolves under time. So here, if we are taking one example, we can say the response of single mass spring damper in a free vibration in a laboratory. Now we can see about the random process. Deterministic, we are saying it will have only one possible reality of how process evolves under time. But for the random, we are saying many time varium signals are random in nature. So we can say random process is a collection of random variables which are indexed by a time, and random process will represent the mathematical model of this random signal. So here we are saying if we are taking the result of large number of separate causes that is described in a probabilistic terms and by properties which are averages, at that time we are saying that as a random process. So here you can observe the diagram, the waveform. So here we are taking on the x-axis time t and x of t. This is nothing but it is the simplified notation for the random process. So here we are saying random process is a collection of random variables and that will be indexed by a time. So here we are saying t is a time and s we are denoting for the sample point of a random experiment. So here we are taking the simplified notation for the random process as a x of t. So here if you see in this waveform we are taking the samples and we are supposed to take their collections. So here the probability density functions describes the general distributions of the time magnitude of a random process. If you observe this waveform, you can see here time is distributed over the samples. So here, but it gives no information on the time or the frequency content of the process. So here we will see about the averaging and the stationarity of the random process. So here we are saying random process we can represent the mathematical model of the random signal. And if random signal are having the function of time, we are calling that as a random process. So we are supposed to take here collections of the random functions that will be indexed by a time. So it will give us the random process. So here we are supposed to see about its averaging and a stationarity. So here we are supposed to see about the underlying process, the sample records which are individual representations of the underlying process. And we are supposed to study about the averaging. So here ensemble averaging and the time averaging. The properties of the random process which are obtained by taking the average over a collection or ensemble of a sample records using the values at corresponding time. At that time we can say that as a ensemble averaging. Then we are saying about the time averaging. So here we will get the properties that are obtained by taking the average over a single record in a time. So here we are saying if we are taking the collections of random variable over a function of time, at that time we can say that as a random process. So if you see, there are some differences between the random variable and a random process, because random variable, it is the outcome, it is mapped to a number. And if we are talking about the random process, we can say it is an outcome which can be mapped to a random waveform. But here it is the function of time, and random variable, it is not a function of time. It is only mapped to a number. So here we will see about random process. Now we want to see there are different types of random process like stationary random process. So here if we are taking the collection average, that time if it is not vary with the time, at that time we can say that random process as a stationary random process. Then ergodic process, it means what? There is a stationary random process in which averages from a single record are the same as those which are obtained from averaging over the ensemble. So here most stationary random process can be treated as a ergodic, because here we are saying about the ergodic random process. So here we are using ensemble. Ensemble is nothing but it is the set of, or we can say the collection of all time varying functions. So here if that collection average do not vary with time, at that time we are saying that as a stationary random process. So here if stationary process in which averages from single record are the same as those which are obtained from averaging over the collection of time varying functions, at that time we are saying that process as a ergodic process. So here most stationary random process can be treated as a ergodic. If you see, wine loading from extra tropical synoptic gates can be treated as a stationary random process. And if you see about the wine loading, at that time we can say there we will get the stationary over the shorter period, that will be less than 2 hours. And if we will talk about the wine loading from the hurricanes, you can take non-stationary over the duration of the storm. So here now we are supposed to study about the mathematical different parameters which we are supposed to calculate for the random process. And here we are saying random process is defined as the collections of the time functions, or we can say random process x of t is defined as ensemble of the time functions together with probability rule that assigns the probability to any meaningful instant associated with an observation of one of sample function x of t. So here we are supposed to study about the mean value, autocorrelations of the spectral density of the random process. We will see these things in the next class. Thank you.